Go ahead, Nishka.
Yeah. Can you see my screen?
Yes. Click present and present.
Yes.
Okay.
So my topic, I wanted to go over plant-based coatings for nanosensors. My name is Nishka Mehta. I'm in 11th grade and I go to International Academy East. So in environmental monitoring, nanosensors are essential for detecting pollutants with really high sensitivity. They use special materials to find contaminants like heavy metals and organic compounds, even at very low levels. Scientists are now testing plant-based coatings to make these sensors work even better. These coatings, made from natural compounds found in plants, could improve sensor stability and how well they grab onto pollutants. And my research question was, how can plant-based coatings on nanosensors improve the sensitivity and specificity of environmental monitoring applications? In the study by Hassana and colleagues, the focus was on constructing a hydrogel pectin-based triglyceride optical biosensor with immobilized lipase enzymes. This biosensor aimed to address the need for effective monitoring of triglyceride levels, which is a crucial parameter in environmental diagnostics. By incorporating plant-derived hydrogel pectin as a matrix for enzyme immobilization, the researchers demonstrated a novel approach to enhancing the sensitivity and specificity of nano sensors in environmental monitoring applications. This utilization of plant-derived materials not only improves biocompatibility, but also optimizes the performance of the biosensor, enabling accurate detection of triglyceride levels in environmental samples. Meanwhile, in the work of Aguilar Perez and colleagues, the focus was on nanobiomaterials, sensing and detection cues for environmental pollutants. This comprehensive review basically explores the use of nanotechnology in environmental sensing and detection. The authors discussed a diverse application of nanobiomaterials, including metallic nanoparticles and carbon nanotubes in environmental diagnostics. These materials offer fast, sensitive, and cost-effective solutions for detecting a wide range of pollutants in water and soil matrices, with the incorporation of plant-derived materials, which makes the nanosensors better. So nanosensors are invaluable tools in environmental monitoring. One notable example of plant-based coatings enhancing nanosensor performance was found in the NovioSense glucose sensor. But it's positioned in the lower eyelid fornix and immersed in tear fluid. This sensor benefits from a specialized hydrogel coating derived from plant-based materials. This coating not only ensures that the wearer is comfortable, but also serves as a protective barrier, shielding it from environmental factors. A lot of plant-based coatings offer a bunch of advantages for nanosensors, like green synthesis, so leveraging plant extracts in the synthesis process, which promotes eco-friendly manufacturing methods, which reduces the environmental impact that is usually associated with the sensor creation. Because they are derived from natural sources, these plant-based coatings are inherently non-toxic, which makes them safe for both environmental and biological applications. The use of plant-derived materials enables rapid production of nanoparticles, which makes the overall process a lot faster. And all of these coatings are very compatible with environmental and biological systems, which means that they can be used in a wide range of environmental applications. And the application of plant-based coatings extends to various parts of environmental monitoring. These coatings can enhance the sensitivity, selectivity, and stability of nanosensors, which enables efficient detection of environmental contaminants such as heavy metals in water and pollutants in soil. By providing an additional layer of protection and stability, plant-based coatings contribute to the preservation of environmental health and sustainability. In conclusion, plant-based coatings are a very promising avenue for optimizing nanosensor performance. Their eco-friendly synthesis, non-toxic nature, and biocompatibility make them invaluable components to the development of sensor technology. Thank you. My
With gift at Gabber? Yeah, go ahead. You don't need to share a
Yeah.
presentation. You can just go ahead.
I'm sorry, what?
Your experience with the program.
Yeah, this program was really helpful to me in many ways. I have written research papers before, but I was never able to write a scientific research paper, and this program actually gave me time to do that, and so many resources, like Professor Lilova. She helped me narrow down my topic from originally it was just going to be talking about plant-based nanosensors, but she's the one who helped me narrow it down to the coatings because she couldn't find much on the actual nanosensor being plant-based themselves. And Professor Virgil, like I said, I've written research papers before, but he's the one who basically walked me through writing a scientific research paper. Yeah, and Gifted Gabber gave me the resources and the time to be able to do this.
Excellent. Excellent. So questions for Nishka, Dr. Lilova?
Yeah, actually, I have a question I wanted to ask before. How did you come up with this idea? Because it's a great idea. I really like it. It is very specific. Plant-based coat nanocarriers because they're biocompatible, of course, and we want this and they're cost-effective. So how did you come up with that?
This might be a little silly of an answer. I had a friend that was actually really interested in environmental studies. And when I mentioned that, hey, I'm trying to figure out a topic for this, she was like, can you go through this research paper with me? So with her, she helped me find out, this would be a great thing to talk about.
That's not silly. It's called collaboration. And that's what we do. And we collaborate with people from different fields, and that's how we come up with ideas. That's a great way to go.
Thank you.
Yeah.
Excellent. Excellent job, Nishka.
Good.